Hello everyone. This circuit is about a purely resistive AC circuit. So in this tutorial we shall actually see that in a purely resistive AC circuit, the voltage and current are in phase. And what I mean by that is that the voltage and the current will both rise and fall together at the same time. There isn't any time difference between the time that the voltage achieves its peak or maximum value and the time that the current achieves its peak or maximum value. So for that matter, they both achieve their peak, that is maximum and minimum values, the same at the same time. And that's what this experiment we are expecting to see, this tutorial we are expecting to see. We are going to simulate this circuit here, and I have a purely resistor of 1 kilo ohm resistance connected to this alternator or generator of voltage 1 volt and frequency of 1 kilohertz. Before we do this, we have to get the measuring instruments. Other than that, we can't probe this circuit. So let's go and get the measuring instruments. I'll pick the voltmeter and drop it here and pick the ammeter and drop that one too here. So now the circuit is good to go and we are going to probe it. So let's click on the simulation and start probing it now. What I want us to do is to quickly click on this here. Now we can't really see the difference between both the current and the voltage. So what I'm going to do is to click inside the graph and go down here and change the values of the current. So here I will make it 0.002, and this side I'll make it 0.02, so that at least I can actually see the difference between the current. Now the probe for the current is the blue dot lines, and then the probe for the voltage is the what is it called? Probe for the voltage is the green dotted lines. So what I'm going to do is that I'm going to stop simulation and I will just go straight to only grapher. And now let's do this. Let me change this to cursors here. So I'll go and change the cursor 1. I'll let the cursor 1 stay as voltage, and then cursor 2 stay as current. So I've got cursor 2 as current. That can measure the maximum value of the current. And when you look at current, the maximum value for current, it's approximately 1 milliamp. Okay, it's 989.28 microamp. Now let me put the voltage here, and it's also 992.15, approximately 1 volt. Now let's see if it is true. Now you can see from here that they both rise, okay, and fall together. Both the voltage, which is the green wave, and then the current, which is the blue wave, they all both rise and fall at the same time. But I will show you what I mean by rise and fall at the same time. But you can see that they both rise and they have the same frequency. They have the same frequency and they have the same for one cycle. They have the same frequency. So if you look at here, they have the same period, and the period is 1 micro, that is 1.0330 microsecond, and the frequency is approximately 1. If I put it exactly on it, I should achieve a frequency of almost 1. Yeah, you can see the frequency here, 1 over delta x. That's the frequency. So they all have the same frequency, they have the same periodic time. Now let's see if they both rise and fall together. So I'm going to take this one to this here. They should all be in the same line. And let's look at something here. So if we look at the cursor one, which is meant for the voltage, the time is 20.147 seconds. Okay, that is when it achieves its maximum value of 997.92 millivolts. Now let's look at the time that current achieved its maximum value, and it's the same 20.147. The time that it took the current also to achieve its maximum value of 990.30 microamp is 20.147. So in short, you can see that they both achieved their maximum values at the same time. They achieved their maximum values at the same time, which tells us that they are in phase. They rise and fall together at the same time. The voltage achieved its maximum value 20.147. Current achieved its maximum value at 24.147. So that is why that is why we say they are in phase. Okay, now let me take this one to 0 here. Let me take that current also to 0. Okay, and you will see that the same. Okay, when we look at the time that the voltage achieved 111 picovolts, and picovolts is not point, not, it's 12. The micro is 10 to the power minus 6, so it's approximately 0. And that time, the minimum 0 here is 20.146, and for the current too, at 0, approximately 0 is 20.146. So you see that they both achieve their maximum and minimum values the same time, which means that they are in phase. So this is what a purely resistive circuit in a purely resistive AC circuit is. So thank you very much for watching, and keep expecting more videos. So in short, in a purely resistive AC circuit, both the current and both the current and the voltage rise and fall together, or there is no phase difference between the voltage and the current. There is no time difference or angular difference between the time that the voltage achieves its maximum or minimum and the time that the current achieves its maximum or minimum value. Thank you very much.